are up and running almost to the next session. We got a poll from AXIOM Tech, which will present the last case from ROBE Lightning. As I already said this morning, one of the world's most innovative lightning manufacturers, and which has partnered with Siemens. I wouldn't say, of course, but for sure it has a big advantage to do the transformation and the operations. To actually really bring a cool world-class product to the market and faster than ever before. So, Otta, please take your way and present us your case. Thank you very much.
Thank you, Moose. Hello, everybody. I hope you have a good day today. Do you see my screen? I already share the presentation, yes, so just a quick confirmation. Thank you.
All fine.
So great, so let's get on it. So good afternoon and welcome to my presentation that is part of this year's Solid Edge University. And the topic of this presentation, as Moose told you already, is introduction of ROBE Lighting company and its successes, which it has achieved, among other things, with software solutions from Siemens. The agenda of my presentation is as follows. So first, let me introduce myself and AXIOM Tech, which is a Siemens partner, who we are and what value can we bring to our customers and other partners. Next, I will introduce ROBE Lighting in more detail, and then I would like to briefly mention about their design software history. And I will then show you some practical use cases where ROBE's development department has successfully used the Siemens Solid Edge software solutions to significantly help them increase their productivity and the quality of their great products. So first, let me introduce myself in more detail, and I will introduce our company, AXIOM Tech. My name is Otta Paul, and I work at AXIOM Tech company as a product manager for the Solid Edge portfolio. AXIOM Tech is an important partner of Siemens Industry Software in the Czech Republic, and we have been a supplier of various complex software solutions and tools for over 30 years. Our main activities include sales and support of Siemens softwares, and we also provide trainings, consultings, and mentoring to our customers. And we also carry out various analyses and technical audits for our customers, and we can provide design services where we can offer the capabilities of our experienced design engineers from various industries. Our company, AXIOM Tech, has many years of experience in the digitalization that we offer to our customers. We operate in three main areas. The first is design area. In this area, we provide companies with software for design and engineering activities. We have our own development and design team where we offer our services related to the development and innovation of our customers' products. Another area of our specialization is software solution designed for various simulations such as strength, thermal, or other specialized tasks. Along with these solutions, we also offer services. For example, if a customer has a product that needs to be optimized for fatigue, durability, strength, or flow, we are able to offer these services as well. In addition, we supply and implement PLM software solutions that help development teams effectively manage documentation through the product lifecycle. We can prepare PLM solutions for small companies with specific needs, but also for medium and large companies, along with extensions to the areas of manufacturing, costing, or project management. And we also specialized in the development of custom applications that help automate repetitive processes in design departments in our customers. The second main area of digitalization that we cover is generally manufacturing. We provide to our customers a comprehensive Siemens CAM solution for generating machining code according to 3D model of the parts. We also supply post-processors, which translates the NC code and ensures the correct production of the part on a given CNC machine tool. We also supply verification software for machining. This kind of software allows to take the NC code and verify it for collision with the spindle or other parts of the CNC machine. It can then modify the machining NC code before production to make the machining more efficient, thus producing the part faster and without the risk of any collisions. We also provide tooling management solution, and as in design area, we offer PLM solutions to manage processes, resources for production. We also offer PCM software implementation that can calculate the cost of manufacturing a part very accurately based on the analysis of the part's topology. And in the third area of digitalization in which we operate is software solutions for the digital twin of production itself. So in these solutions, the customer has a complete 3D model of the production, which can be used to simulate the entire production processes. This digital twin allows us to analyze all bottlenecks in production, such as various downtimes and carryover, and can offer optimal solutions to remove these bottlenecks and increase productivity. Simply put, it is a software solution for making production processes more productive. We also offer solutions for advanced operational planning, which can be linked to various ERP systems to automatically schedule production orders for individual machines and workstations. This enables the customer to schedule orders automatically, including eliminating downtimes, waiting for inputs, or missing resources. Furthermore, within this area, we also offer software that is used to validate the design of the entire production line with robots and manipulators. This is a solution that will verify the feasibility of automation, robot reaches, or line flow, and can simulate the entire production line while also allowing offline programming of industrial robots and virtual commissioning. In summary, for all these main areas, design, technology, and production, we can link data, automate data transfers between different software and ERP systems, simplifying the work of designers and operators. We have been expert in digitalization for over 30 years, and we are one of the most important digitalization supplier of Siemens portfolio software in the Czech Republic. So now let me introduce you to ROBE Lighting Company. ROBE Lighting is a global leader in the world of professional lighting solutions. ROBE was founded in 1994 in the Czech Republic, and from the very beginning, it has been driven by innovation, creativity, and strong focus on quality. The company designs and manufactures intelligent lighting fixtures that power some of the most impressive production around the world, from concerts and festivals to television, theater, and architectural installations. ROBE is also known for its commitment to developing sustainable, reliable, and future-forward lighting technologies. Over the years, it has grown into a respected brand trusted by lighting professionals across many industries. ROBE isn't just a leader in lighting tech, it is a true global player. The company employs over 900 people worldwide, and its products are distributed in more than 100 countries through a strong network of subsidiaries and distribution partners. ROBE handles its entire development process in-house, from research and design to manufacturing and testing. Everything is based at the company's facility in Valašské Meziříčí in the Czech Republic, and this allows ROBE to maintain strict quality control, remain flexible in innovations, and deliver consistent quality on a global scale. Let me share with you one interesting fact. ROBE was one of the first companies in the Czech Republic that purchased a commercial desktop 3D printer, and they used it to print prototypes of plastic covers for its luminaires, which significantly contributed to accelerating product development. So the key to ROBE success, it is commitment to technological innovation. The company offers a full portfolio of intelligent lighting products, including moving heads, wash lights, LED effects, and many more. What sets ROBE apart? It is focused to durability, performance, and optical precision. Their fixtures are engineered for demanding environments, from live concert stages with frequent handling to controlled broadcast studios. ROBE has earned its place at high-profile events like Eurovision, and it's regularly used in large-scale live shows, corporate events, and permanent installations. The company also leads in energy efficiency and green design, working to minimize environmental impact and extend product life cycles. So simply put, ROBE is lighting the future with innovation. So ROBE is also deeply invested in customer success. They offers comprehensive support, training, and education to lighting professionals around the world. Their products consistently win awards for design and innovation, and their team continues to push the boundaries with each generation of lighting solution. Overall, ROBE is a company that understands both creative and technical challenges and who can help elevate any lighting production to an unforgettable experience with their future-ready tools and products. So now let's briefly talk about ROBE's history in terms of the software solution they have used in the past and are using for their business today. ROBE began actively utilizing design software around the year 2000 to enhance the efficiency of product development and luminaire manufacturing. Initially, the company implemented Unigraphics, which was primarily used for 3D CAD modeling of complex shaped plastic covers, designing structural assemblies, and preparing data for CNC production. For the design of internal mechanical parts, such as brackets, mounting frames, and basic structural components, VariCAD and AutoCAD were used, mainly for quick 2D design and 3D model designs. But with increasing demands for design complexity and integration of engineering changes, the company transitioned around the year 2006 to Solid Edge. And this CAD system became the main platform for complex 3D assembly design, parametric modeling, and preparation of manufacturing documentation. And Solid Edge remains the primary design software at ROBE today, covering the development of all plastic and metal parts. Over the years, their design capabilities was expanded with additional specialized CAE tools. First was FEMAP solution that was used for structural analysis of mechanical behavior, allowing testing of strength, deformation, vibration, and optimization of structural components before physical prototyping. It was primarily applied to key mechanical parts such as arms, hinges, and support frames of luminaires. Another CAE tool that is in use today is Siemens SimCenter Flow EFD for Solid Edge that enables simulation of airflow and thermal analysis directly within the Solid Edge CAD model environment. This tool is essential for the design of LED module cooling, optimization of ventilation within enclosed fixtures, and simulation of heat dissipation from electronics, for example. So now let's take a look on some practical use cases where ROBE's design department has successfully used the Siemens Solid Edge software solutions to significantly help them increase the productivity and quality of their products. First use case is about challenges in the design of bent sheet metal parts. In the area of sheet metal part design, ROBE lighting has long faced a challenge based on the high variability of the material used. In particular, aluminum and steel sheets are processed in a wide range of thicknesses, and this variability in material thicknesses and properties often caused issues in the calculation of the flat pattern shape of the sheet metal bent parts, which had a direct impact to the quality of production and the need for frequent additional modification and corrections. For these reasons, it was necessary for the ROBE design department to pay detailed attention to the precise calculation of the flat pattern shapes. Based on practical experience and in cooperation with their production engineering department, designers developed internal system that was used to correct the neutral factor according to the combination of material thickness, material type, and die used in production of the bending machines. This correction was then applied manually by the designers during the creation of the models, which was time-consuming and required considerable care to ensure the proper flat pattern dimension and minimize manufacturing errors. But until recently, the issue of accuracy of sheet metal flat patterns was addressed by an increased number of prototypes. Sheet metal parts were first produced according to the calculated flat patterns, then checked and corrected if necessary. While this process was efficient, it led to increased costs and increased time to bring the products into production. So with the release of the latest version of Solid Edge 2025, ROBE has taken full advantage of the new options for calculating sheet flat metal patterns. The bend calculation methods are now controlled by a custom Excel spreadsheet that is linked directly into the CAD environment. Following this new functionality, the original in-house system has been redesigned to be fully compatible with Solid Edge 2025 and expanded to include the current range of materials and thicknesses processed and optimized in terms of data structure and loading speed. The new version of this Excel spreadsheet now precisely defines the specific sheet metal properties and the assigned adjusted neutral factor values for each combination of material and bending technology that ROBE uses in production. This information was subsequently integrated into the company materials library in Solid Edge, resulting in data standardization and full automation of flat pattern calculation when creating new bent sheet metal part designs. The process for the design of sheet metal bent part now is as follows. When creating a sheet metal part, the designer selects the appropriate material from the material library, including the thickness specification. Based on this selection, Solid Edge automatically sets the correct base material thickness and assigns the appropriate neutral factor values to 3D model of sheet metal part. These parameters are then automatically applied when calculating the flat pattern, ensuring it is always correct. In this way, the accuracy of the flat pattern shapes has been significantly increased, reducing the need for the prototyping, reducing the time required to bring the product into production, and minimizing manufacturing errors and associated costs. So with the implementation of this new feature in Solid Edge 2025, ROBE's design department has gained an important tool for more efficient design of sheet metal parts. Full integration of the calculation of flat patterns according to the real production conditions means an end to manual adjustment and experiments. The system now automatically selects the correct parameters and ensures consistent results across the entire development cycle. The benefits are clear here. Fewer prototypes, shorter development times, reduced costs, and, most importantly, higher quality output data. As a result, designs are prepared faster and more accurately, and the entire process of moving to production is smoother and more stable. So by taking this step, ROBE Lighting has not only increased its productivity, but also strengthened standardization between design and manufacturing, which is key to repeatability, scalability, and future growth. So let's go to look on the second use case. This second use case shows the practical use of a simulation software to verify the structural strength of a particular design. So the goal of this study of this analysis was to verify the strength behavior of a structural unit containing a clamp connection intended for mounting on a circular beam. The structure is made of aluminum silicon stainless steel and will operate at an ambient temperature of 20 degrees Celsius. The strength assessment was based on a combination of self-weight load, the weight of the mounted reflector, and the preload from the bolts. In order to increase the reliability of the analysis, two methods were used: the linear static analysis according to the European standard, and the advanced geometrically and materially non-linear analysis, which allows us to take into account the occurrence of plastic deformations. The numerical model of the structure was created in FEMAP and Solid Edge simulation. This numerical model of the assembly was defined by combining a mesh of tetrahedral elements, surface mesh, and 1D elements that represents the bolted connections. The study was divided into two parts. In the first part, the maximum tightening force of the bolts without plastic deformation was determined while neglecting the operational load. The second part of the task subsequently evaluated the design of the structure with operational load, using the bolt preload determined from the first task as an additional input parameter. So in the first part of the analysis, the objective was to find the maximum tightening force of the bolts to avoid plastic deformation during assembly. Before the calculation, a tightening force of 30,000 newtons was considered. However, a limit of plastic deformation was identified at a force of approximately 24,000 newtons. So after taking into account a requested safety factor of 3, the maximum safe tightening force was determined to be 8,000 Newton, which corresponds to recommended tightening torque of approximately 21 Newton meters. So the second part of this study, of this analysis, focused on verifying the design of the structure under realistic loading conditions. That means the combination of self-weight load, the load from the mounted reflector, and the allowable preload of bolts calculated from the first part of this task. The resulting stress, according to the von Mises criteria, was lower than the allowable stress for the stainless steels considered. The only area where the allowable stress was locally exceeded was the contact between the clamp and the support beam. However, this was a stress spike caused by contact, not a critical overload that would lead to failure. So for these reasons, the overall design was considered to be satisfactory from a strength point of view. So this study successfully confirmed that the clamp joint design is suitable for mass production in terms of strength. The study sets the safe limit of the bolt tightening torque and subsequently verified the design under operational load, confirming that the design easily meets the strength requirements by ROBE. Importantly, the way in which these results were achieved was by using modern CAE tools, namely Solid Edge Simulation and FEMAP solution. These software tools have made it possible to accurately predict not only the overall strength of the structure, but also local stress concentrations. So this made it possible to eliminate the need for physical prototypes, speeding up the design process and increasing its reliability. So now let's take a look at the third and last use case that shows the practical use of a thermal simulation software to optimize the heat source cooling inside luminaire. The objective of this study was to design a more efficient cooling system for the heat source chip placed inside a new type of luminaire. Copper heat spreaders, heat pipes, and aluminum heatsink with axial fans were used to dissipate the heat from the heatsink. Solid Edge and SimCenter Flow EFD software tools were used for this study. One of the advantages of used software solutions is the ability to perform analysis directly on a 3D model in Solid Edge kit environment without the need to convert and transfer data between different software tools. Computational fluid dynamics, thermal, and flow analysis was used for this study. The goal of this analysis was to find a cooling design with respect to reducing the noise from the fans so that the fans do not have to run at full speed. Another important condition in terms of structural design was to maintain the external dimension of the entire cooling assembly due to the limited built-in space. Two design variants of the heatsink were considered for the simulation, based on previously used heatsink designs. The first variant included 6 fans located on each side of the heatsink. The second variant considered 2 extra fans, which were placed in the middle of the aluminum heatsink. For analysis, the high-quality finite element mesh was created automatically with minimal user intervention. The density of the mesh is simply set by a slider, with local refinement and boundary layers defined automatically by the FlowVFD software on behalf of the user. The analysis found that when using the 6-fan variant, the total cooling surface area of heat dissipation is larger compared to the 8-fan variant, but the airflow around the fins of the heatsink is slower. In order to achieve a higher airflow rate, more powerful fans would be required. So when using 8-fan variant, the heat source is better cooled due to this faster airflow, even though the total cooling area is smaller compared to the 6-fan variant. So using fluid thermal analysis, possible design options for cooling the heat source inside the new luminaire were verified. This analysis showed differences in the considered heatsink design options, where the variant with 8 less powerful fans is more efficient in terms of cooling, as it guarantees more airflow and has 8% higher cooling efficiency than the variant with 6 more powerful fans. This simulation result was then verified and confirmed by measurement on a real heatsink. By combining Solid Edge CAD software and SimCenter FlowVFD simulation software, it was possible to perform this analysis, verify the behavior of the different design options, and evaluate which cooling option is more efficient. Again, as in previous use case, this made it possible to eliminate the need for physical prototypes and speeding up the design process. But simulation analysis is not just a tool for verification, but is now in today key element in efficient development of new products at lower costs. Simulation software tools shifts development from trial and error to smart simulation-driven engineering. So, designing world-class lighting system requires more than just a software. It demands trusted tools. And with Siemens Solid Edge, ROBE accelerates development while maintaining full control and confidence from concept to production. With Solid Edge, ROBE streamlined its development using tools tailored for plastic parts and sheet metal design, complex assemblies including electronics, stress and flow analysis, and built-in manufacturing logic. They have also significantly reduced need for physical prototypes with Solid Edge, which helped them speed up the design process and increase the reliability of their products. So, thank you. We have reached the end of my presentation. Thank you very much for your attention, and please do not hesitate to contact me if you have any more questions, and I wish you a pleasant rest of the day.
Thank you very much, Ota. I highly appreciate your presentation, and let's see how we can close the whole session here now. So, looking at all the presentations which we have done, I think, wow, it was really a great day until now. On behalf of Siemens and everyone else that has made actually this event possible, I want to thank you for your valued customers and partners and colleagues, for your energy, curiosity, and your passion. We came together today to explore the future of design engineering and manufacturing out of the perspective of Siemens, of course, but also in many cases also from the partner. We have heard some great news from some great minds in our industry, like Dan Staple, John Southcliffe, and many more. And also I want to thank many times also to Natalia Ilinia, who is pretty new in the region, not so new, but pretty new in the region of the CE, that she engaged with us. And I think it was great that the partners were here with all the good presentations. So what I would like to do now is, I hope you leave today with some new ideas, practical insights, and most of all, the confidence to lead your own digital transformation journey. Remember, the transformation is not about technology alone, but really, in many cases, about people, you, the vision of you, what you have for your company, for your business, and the courage to move forward, and when actually other companies are hesitating to have this integrated. Now, maybe some housekeeping reminders quickly. The final reminder points before we close. This entire event has been recorded by Michal and the team, and we will share all the sessions. I'm not sure if we will share them all in one bit or if we cut them up. I think it would be great if we could cut them up and divide them, bringing them out. I saw also some questions coming in. We will, of course, answer them. If not now in the call, then for sure you get feedback from us to your team and to yourself. We always welcome feedback also after the event, if something was not so good also, so we can learn also and get better. And let us know what you liked and what you inspired and what we can do even better for next time. So some final words. I would like to give you some heads up also. So there are 2 webinars which I would like to promote also. So one webinar is next Thursday. I will post the link into the chat after we close. So one is actually near battlefield repair. That's a defense standard webinar on model-based definition with great examples, with a great customer story also, and some very exciting how shall I say, technology. We have Ingenia from the Netherlands who is doing the 31K standards for whole EMEA actually on the defense industry based on NBD. So I saw some questions flying past. So it might be something which you want to join. And the second one is actually looking at how you can optimize resources, managing cost efficiently, streamlining integration with, of course, CAD, specifically of Solid Edge. This one, I will post also into the chat. So if you have time, if you have some stamina, let's say it like this, please join. I would really like that. And now I would say, as I stand here looking at this fantastic community today, I feel incredibly proud and optimistic. Together, we are shaping the future of engineering and manufacturing. Let's continue to challenge ourselves, push boundaries, and innovate creatively. And thank you again for your trust, your partnership, and for spending the days with us. Thank you very much, and have a good day.
Thank you very much, Moose. Thank you very much, everyone also.
Yeah, thank you. Thanks, Moose. Thanks, Michael.
You're welcome.